topic for the Science 9, the carbon compounds. So we have the following objectives for this lesson. At the end of the session, the learners are expected to first, recognize common kinds of properties of organic compounds. Second, understand the types of bonds formed in alkanes, alkenes, and alkynes. And the last one, illustrate the structural formula and condense the structural formula of alkanes, alkenes, and alkynes. So for the first part, we have here the task number 1, what's the word? Rearrange the scrambled word to unlock the term being defined. So we have here 4 definitions with these scrambled words. So you are going to rearrange to get the correct term that is being defined in each number. Number 1, it is the smell of the compound. Number 2, it is a measure of a liquid's resistance to flow. Number 3, measure of how easily the material burns. And number 4, the measure of the tendency of a compound to evaporate. Alright, now let's reveal the answer. For number 1, the smell of the compound is odor. Number 2, measure of a liquid's resistance to flow. The correct answer is viscosity. Number 3, the measure of how easily the material burns. And the correct answer is flammability. And the last one, the measure of the tendency of a compound to evaporate. The correct word is volatility. Very good. Now, let's proceed to the next task. Task number 2, where do I belong? To the direction, put the pictures to its corresponding use or uses. Okay, so we have here different pictures of the common products as well as crop that can be seen in the surrounding. First picture, we have the nail polish remover. So where does the nail polish remover belong? Is it a beverage, food, antiseptic, fuel, or cleaner? Alright, nail polish remover is a cleaner. Next, we have the LPG tank. LPG tank, its corresponding use is a fuel. Next, we have kerosene. Kerosene is used as fuel. Next, we have the alcohol. Alcohol is used as antiseptic. Next, we have ethanol. Alright, ethanol is used as beverage and can also be used as antiseptic. And we have the vinegar used as food. And the next picture we have the rice. Rice crop belongs to food. And the last one we have lubricating oil or the lubricant oil. So it can be used as fuel and a cleaner. Very good. Now let's proceed. The next slide. What do you think are the characteristics of the materials which give their uses? So we have here the compounds, and the second column is its uses. First is the gasoline. Gasoline, that is fuel for vehicles. Kerosene, used as a fuel for lamps and portable cooking stove. LPG, or the liquefied petroleum gas, is used as fuel for gas stove and cars. Ethanol, used as a disinfectant, and used as main ingredient in liqueurs. We also have the acetone, used to remove nail polish. And the last one, the acetic acid, or also known as the vinegar. It is used as component of vinegar and used to treat fungal infection. So, these compounds, ito yung mga nakikita natin kanina sa picture sa second task. Why do you think this kind of organic compounds are very important? Well, the answer is these common organic compounds are important because they have many uses at home and in the industry. Now, we have here the explore part, or the main activity of the lesson, which is the hydrocarbons. So this activity can be found in your book, in your Science 9 book. The materials needed for this activity, we have the bond paper and pen. So please prepare your materials and follow the procedure with your group mates, or you can do this by pair or individual. Use the data in tables 1 to 3 to answer the questions in this activity. So table 1, we have here the alkanes. On the first column, we have the name, phase, condensed structural formula, and the boiling point. So all you have to do is study and observe the table. So table 1, alkanes, starts from the methane up to the octane. Table 2, that's the alkenes. Observe and study the table. Next, we have table 3, the alkynes. So after studying and observing the three tables, alkanes, alkenes, and alkynes, you have to answer the guide questions. So you can pause the video or look at your book to read the three tables. And after that, answer the guide questions. First question we have, what are the types of bonds present in the following? Alkanes, alkenes, and alkynes. Second question, using tables 1 to 3, what pattern do you observe in terms of the phase, number of carbon atoms, structure, and boiling point of the alkanes, alkenes, and alkynes? Question number 3, what do you think will be the boiling point of the next alkane, alkene, and alkyne? Will the boiling point of each hydrocarbon be higher or lower? Explain your answer. Question number 4. Why do you think some hydrocarbons are gases and others are liquids? Question number 5. Why do you think there are many hydrocarbon compounds? And the last question, what hydrocarbon compounds are gases and liquids? What are the uses of gaseous hydrocarbon compounds and liquid hydrocarbon compounds? So you have 15 minutes to answer the guide questions. You can reread the tables 1 to 3. So you need to see the relationship of its structure, boiling point, and the phases. Okay, now let's reveal the answer. For question number 1, what are the types of bonds present in the following? Alkanes, alkenes, and alkynes. So the answer is, compounds in the alkanes group only have single bonds between carbon atoms. Alkenes have at least one double bond between carbon atoms and in the compounds. Alkynes have at least one triple bond between carbon atoms in the compound. So again, for the alkynes, they only have single bond Alkenes have at least one double band, and alkynes have at least one triple band. Next question. 1 to 3, what pattern do you observe in terms of the phase, number of carbon atoms, structure, and boiling point of the alkanes, alkenes, and alkynes? So the answer, the physical state of the alkanes from methane to butane is gas, and from pentane to octane is liquid. The reason for this is related to the structure of the compounds. If the molecules of the compound is small, it interacts less with each other. Just like methane, it is likely to be a gaseous compound. When the molecules become bigger in size or structure, they can closely interact with each other and they will become more likely to be liquid, just like in the case of octane. Octane molecule has a very long chain structure that makes it too heavy to be a gaseous compound. The trend in the phase of the compounds is also the same with the alkenes and the alkynes. The phase of the alkenes and alkynes is a gas when the molecules is small and becomes liquid as the molecules become bigger. The trend in the structure of the compounds in alkanes, alkenes, and alkynes is the same. The size of the structures of the compounds is increasing because the compounds become bigger or longer. Question number 3. What do you think will be the boiling point of the next alkane, alkene, and alkyne? Will the boiling point of each hydrocarbon be higher or lower? Explain your answer. So the answer is, the trend in boiling point of the compounds in alkanes, alkenes, and alkynes is also in an increasing pattern. This is because of their structures. As the structures of the compounds become bigger, they will also interact with more with each other. Bigger molecules that interact with each other more strongly require higher temperature to evaporate. That is why they have a higher boiling point. Question number 4. Why do you think some hydrocarbons are gases and others are liquids? So the answer is, the reason why there are hydrocarbons that are liquids and gases is because of the structure or the size of the molecules of the compounds. When the molecules are small, they tend to interact less among each other. Smaller molecules are usually gases, and when molecules have bigger structures, they interact more with each other. Thus, bigger molecules tend to settle in liquid state. Question 5. Why do you think there are many hydrocarbon compounds? The reason for so many hydrocarbon compounds is the carbon atom. Carbon atoms have 4 valence electrons. This atomic structure of the carbon makes it possible to form many types of bonds with other elements and with other carbon atoms. The formation of these bonds result in many different hydrocarbons. And for the last question, what hydrocarbon compounds are gases and liquids? What are the uses of gaseous hydrocarbon compounds and liquid hydrocarbon compounds? Common examples of gaseous hydrocarbon compounds are methane, butane, propene, and ethane or acetylene. Methane gas is the most common hydrocarbon. It is used as fuel for cigarette lighters and LPG. It is also mixed with other fuel for vehicles. Butane gas is used as fuel, blended with other hydrocarbons to produce liquefied petroleum gas, and is also used as fuel cigarette lighter. The color of the flame when butane is used in cigarette lighter is blue. Ethane gas, or commonly known as acetylene, is used commonly in flame torch that is used in welding of iron, and it is also used for hastening the ripening of fruits. So here are the key concepts for this lesson. First, hydrocarbons are organic compounds that contain carbon and hydrogen atoms only. Hydrocarbons such as methane, ethane, and butane are components of natural gas. Hydrocarbons are grouped into families, namely alkanes, alkenes, and alkynes. The compounds in each group have certain structures that makes their properties different from the other. Structural formula. It is a formula for a molecular compound that indicates the atoms present and the bonding sequence of the atoms. The covalent bonds between atoms are conveyed as lines connecting the symbols of the bonded atoms. This formula gives a clear illustration about the structure of a compound. So we have here example of structural formula of the methane. So in methane, we have 1 carbon and 4 hydrogen. Next, the condensed formula. A formula for a molecular compound that indicates the bonding sequence without showing all the bands. It should be clear that the carbon atoms are bonded together in sequence and each carbon is bonded to the hydrogen atoms next to the formula. So in our example, this is the condensed structural formula of methane. So from the previous slide, we showed the structural formula of methane. So it shows the bond between carbon and the 4 hydrogen atoms. And in condensed formula, it is shorter and the bonds was not shown. So I'll give you another example of condensed formula. We have ethane. So ethane have the condensed formula of CH3, dalawang CH3. So we will write 2CH3. I'm sorry with the penmanship. Yan. This is the condensed formula of ethane. Now, let's draw the structural formula of ethane. So in ethane plus, we have 2 carbons and 6 hydrogen. So we have to write 2 carbon atoms and 6 hydrogen atoms. So this is how you write the structural formula. So it must be connected or aligned with the number of atoms in your condensed formula. This is H. Alright. So in our example, ethane, CH3, CH3. So we have 2 carbon atoms and 6 hydrogen atoms. So to write the structural formula, here it is. This is the structural formula of ethane. So we have here 2 carbon atoms bonded with 6 hydrogen atoms. So the first part was that is the CH3, meaning 1 carbon atom and 3 hydrogen atoms. And the other part, we have also CH3. So 1 carbon atom and another 3 hydrogen atoms. So that's how you write structural formula given the condensed formula. Next, we have the boiling point, that is the temperature at which a liquid evaporates or becomes vapor. Common groups of hydrocarbons are alkanes, alkenes, and alkynes. So, yan yung nasa activity nyo kanina. They are the 3 common groups of hydrocarbons. Alkanes. So alkanes are hydrocarbon compounds that only have a single bond in the compounds. Alkanes are also known as saturated hydrocarbons because additional hydrogen atoms can no longer bond with in the compound. The first alkane is methane, and the second member is ethane, which are common alkane compounds. Next is we have alkenes. Alkenes are hydrocarbons that have one or more carbon-to-carbon double bonds in their structures. The name of alkene compound ends in E and E. The simplest alkenes are ethene. Its condensed formula is CH2, CH2, and propene. We have CH2, CH, CH3. The last type or the last group of hydrocarbon is it contains at least one carbon-to-carbon triple bond. The most common alkyne compound is ethyne or acetylene. By the way, class, let's review about the different type of bond. So, single bond, example, that's the single bond. They only share once. Okay? Sharing of electron was done only once. Now, for the double bond, the structure will be that's it. It shows two lines, meaning there is two bonds happen between the two carbon atoms. And the last one is the triple bond. So that's an example of a triple bond between two carbon atoms. So the bond represented by a line, meaning they share electrons. So for the generalization, please answer the following questions. Number one, what are the characteristics of organic compounds? Second, how does a specific group of organic compounds differ from each other? Third, why does organic compounds important? So for the generalization, you write your answer in your science notebook. And for the last step, we have your formative assessment. Write the letter of the correct answer. So you write your answer again in your science notebook. Question number one, how many types of bonds can a carbon atom form? A, 1, B, 3, C, 2, D, 4. Number 2. DJ's car stopped at the middle of the road. He found out that his car has run out of fuel. Which compound must they buy? A, kerosene, B, gasoline, C, lubricating oil, D, water. Number 3. Victor's grandmother was cooking their supper when she suddenly stopped and said, "Oh, the tank is already empty." Then her grandmother asked him to buy another tank. What did Victor's grandmother ask him to buy? A, gasoline, B, water, C, lubricating oil, D, liquefied petroleum gas or LPG. Number 4. Ace cut his finger accidentally when he was cutting his nails. He has to apply something on his wound so that it will not get infected. Which compounds should he use? A, formalin, B, isopropyl alcohol, C, kerosene, D, acetone. Last question. Why is it important to know the properties of common liquid materials? A, to know the uses of the liquids. B, to know possible danger from this kind of material. C, to know how these liquids affect people. And D, all of the above. So that ends your formative assessment. Now let's reveal the answer. How many types of bonds can a carbon atom form? The correct answer is letter D, 4. Second question. Richie's car stopped at the middle of the road. He found out that his car has run out of fuel. Which compound must he buy? So when you run out of fuel, you will buy B, gasoline. Third, Victoria's grandmother was cooking their lunch when she suddenly stopped and said, "Oh, the tank is already empty." Then her grandmother asked him to buy another tank. What did Victoria's grandmother ask him to buy? Of course, he will buy liquefied petroleum gas or LPG. 4. Ace cut his finger accidentally when he was cutting his nails. He has to apply something on his wound so that it will not get infected. Which compound should he use? So when you have wound or you cut your finger, you will use B, isopropyl alcohol. Last question. Why is it important to know the properties of common lipid materials? The correct answer is all of the above. So I hope you all got a perfect score. And that ends our topic for today. Thank you very much. And always remember with this code, life is chemistry, dilute your sorrow, evaporate your worries, filter your mistake, boil your ego. You will get the crystal of happiness. Thank you very much and God bless us all.